If you see popping or other similar problems in your RBD simulation, sometimes it's much easier to fix those in a post process instead of in the simulation itself. In my example here, you can see some pretty clear popping on that section at the end of the shot that activates when his hand pulls away, around frame 1074 or so. If I scrub back and forth there, it's this pretty noticeable significant pop. And when the rest of the simulation looks pretty decent, it's a lot easier to just blend that out. This is also a good example of why it can be very useful to have that clump data on your simulation points, because I know that end section is clump 10,002, so I'll drop in a split, connect our sim points to that, and for the group, I'll type in @clump equals 10,002, and we'll have to set this to points, and that'll isolate just that section at the very end there. So if we zoom in on this clump, we can pick out the frames where it's popping. In this case, it looks like there's a big jump from 1074 to 1075. So I'm going to perhaps blend the position from 1074 to 1078. And you can experiment with different durations of that blend, but I'll try 74 to 78 for this example. And to set up that blend, I'll create two time shifts. One I'll set explicitly to 1074, the other explicitly to 1078, and then I'll drop in a blend shape and connect both time shifts to that, and now we can blend seamlessly between those positions. You'll see that by default this blend shape has this option turned on to interpolate the rotation of normals, quaternions, and transforms, and that allows the full transform data to be blended nicely. So it's not just the point positions that are blending here, it's the full transform for those pieces, so the rotation will blend nicely as well. Now you could animate this blend with keyframes if you'd like, but I find it much easier, as I've mentioned before, to use a fit function instead. So I'll type fit at frame from 1074 to 1078, and that'll blend from 0 to 1. So now we have these points smoothly blending across that time range, but we want this to continue with its normal simulated motion after that frame 1078. So I'm going to use a switch to flip this back to the unmodified points, connect our split end section to the second input of that switch statement, and in that switch, I'll check if the frame is greater than or equal to 1078. So now if we scrub across that range, you'll see it's static for 74, smoothly blending and then continuing with that simulation. In my case, I found that there was this clump number 35 that had some pretty jittery motion around frame 1020 or so, and in this case, I can't use a time freeze to blend between the positions, but I'm going to use a time clamp instead. So for this, we'll still use a time shift, and we'll leave this frame expression alone, but we'll turn on this clamp to last option, Control-Shift-Click to get rid of the expression in that end frame there, and I'll change the end frame to 1020. So if we hook that up to our split for this other clump, and we scrub through our timeline, you'll see this has its normal simulation motion up to that frame we've specified, and then it's frozen in time. Now for the blend target though, I'm still going to use a static frame for that. So I'll create another time shift, get rid of that expression, and in this case, I'll use frame 1030 as the blend target. And once again, we'll create a blend shape node, hook up both time shifts to that. And for the blend parameter on this blend shape, I'm going to do something a little bit better than just hard coding in the blend frames. We'll still use our fit function based on the frame, but instead of just specifying the frame numbers, I'll copy these parameters from the time shifts. So I'll right click on this clamp end, and I'll copy that parameter, and I'll paste that relative reference into our fit function here. And then for the second frame number, I'll copy it from our second time shift. So copy that, paste that relative reference in as well, and then we'll still blend this from 0 to 1. And this is nice because we don't have to change the values in two different places with it being hard-coded. With the first blend that we set up, we would have to change the time shift here and the value in our blend shape if we wanted to change the number of frames that it's blending over. Whereas here, we just have to change it on these time shift nodes directly, and then this expression in that blend amount will automatically update based on these two different specified frames on those time shifts. So now, just like our other blend fix, if you view this blend shape here, you'll see that this has its sim motion up to 20, and then it'll blend smoothly across that jittering range. But we still need to have the sim take over at a certain time, so we'll just do the same thing we did before and use a switch statement to switch it back to the normal unmodified motion at a certain frame. And for this switch, I'm also going to use a copied parameter reference. So I'll go to that second time shift and copy that parameter so that this part we don't have to manually update either if we change those frame numbers. So we'll just check if the frame is greater than or equal to that relative reference. So now we have this pop successfully fixed as well. And of course, once we have these various sections fixed to our liking, we have to merge those all together at the very end. So I'll connect that switch and this one and our unmodified points as well. You can alt-click on these wires to create these extra little points to organize your network a little bit better if that helps. And for these blend shape fixes, I like to put little boxes around them just to keep things nice and clean. And as usual, at the end of this, I'll add a null and call this sim points fixed. And you don't have to feel obliged to fix every single pop in your simulation. A lot of the little problems that you might see won't be visible in the final shot. If I pull up this version of the sim, you'll see that there's this additional pop around his head, and it's actually a pretty bad pop, but I decided that for this shot, I really want there to be a lot of dust around that head and hand impact area, so I decided to hold off on fixing that section at the very beginning until I see it with the dust and windows and other secondary elements. This is why it's always really helpful to include at least a basic pass of as many secondary elements as possible when having your shot reviewed in production, so that you don't have supervisors or directors asking you to spend days fixing things that you'll never see at the end.